So the warm-up for today says, if the two graphs below each depict one of the pictured scenarios, which graph represents scenario 1? We've seen these two scenarios multiple times now. They were in our notes last week, and they were in our warm-up question, I think yesterday. And so it's saying here that these two graphs, A and B, one of them represents scenario 1 and one of them represents scenario 2. So with that in mind, which one of those, if that's true, which one has to be scenario 1, A or B? Does anybody have a guess? Or maybe you know. What do you think? Yeah, B. B would represent scenario 1 here because in graph B, there's more time. Okay, if that means that the other graph shows less time, that would be scenario 2. But you can see that as the time increases, the maximum force is decreasing. And we've talked about that relationship, but it's also shown here graphically. Now, these two graphs should have the same area, because the area of our FT graph is impulse, and these two scenarios should have the same impulse. But because the time of the collision is different in each of them, the forces are as well, and those are inversely proportional to one another. We've talked about that several times now, but something to make note of perhaps in your notes yet again if you haven't already written it down. We're going to go over a couple of questions, kind of follow up to this. In just a second, and then that's going to be it for today's notes, because as I've mentioned, there's nothing new in this unit. We're just giving you time to practice using the new stuff we have learned alongside the older stuff. So there's so many equations to pick from now and so many different ways to solve these problems. But again, please answer your warm-up and then submit it, because your warm-up assignment is due today. All right, so here is a follow-up question. Again, I would copy this down into your notes so that you have it to refer back to. It says, a 65-kilogram cyclist crashes into a 1,300 kilogram parked car. The magnitude of the force from the collision is shown by the graph. If the cyclist is initially traveling positive 6 meters per second, find his final velocity. So those graphs are curves. And that red line, that curve, is up on my screen. But we already talked about this. We don't know how to calculate the area under a curve, so we're going to approximate it with a triangle. And that's exactly what you saw in the assignment you had as well. I didn't give you a realistic looking graph because we don't know how to find the area. You do know how to find the area of that, and you've already done it a couple different times because you had this problem, one like it anyway, in your problem set. Okay, so let's go ahead and label our given information. We know that we have a 65 kilogram cyclist, so we know his mass. I don't really care about the mass of the car because we're dealing here with just the cyclist's final velocity, so I'm not going to worry about the car's mass, but it is in the question in the event that I need to go back and pull it later. Okay, the next thing that I'm going to label is the initial velocity of the cyclist as positive 6 meters per second, which is in the question. That's all the information in the question, but there is more information in the graph. So we need to pull information from the graph as well. In that graph, I can see the time of my collision. I can tell that the collision starts at 150 milliseconds and ends at 250 milliseconds. Okay, so the total duration of the collision is 100 milliseconds long. Okay, that is the unit on the x-axis, so just be aware that's not in seconds, it's in milliseconds, which we're going to have to mess with because we can't use milliseconds in our calculation. The other thing that I can get from this is the area of the graph, because the area of a force time graph is impulse. So we'll deal with that in a second, but before we do that, we need to get the time in the appropriate units so that our area has appropriate units as well. So 100 milliseconds in seconds, you need to know this conversion factor because a lot of collisions happen really quickly, and so they're fractions of a second. But milli means 1,000. There are 1,000 milliseconds in a second, meaning that if I divide this by 1,000, that gives me my seconds, 0.1. So the time of this collision is 0.1 seconds. Now I can find the area, 1/2 base times height, but I'm going to use 0.1 as my base rather than 100. Because I want it in seconds. So 1/2 times 0.1 times 9,000, that area is going to be 450. However, you'll notice I put a negative sign in front of it. Guys, why did I mark this as negative 450? Does anybody know? We're not sure? That's okay. Okay, let's talk about why I put a negative. You have a guess?
I think it's because the impulse is also, it might be a stretch, but the impulse is also like equal to the final velocity, and since the final velocity is negative, so is the impulse.
Okay, well, you're kind of on the right track. That's not exactly why. She said the final velocity would be negative because it's going to bounce backwards. Yes, sir?
I think it's because since the car is going in a positive direction, for it to slow down, it needs a negative force.
That's why, and that's why you have a negative final velocity. Okay, when it hits the wall, or in this case the car, it's going to push back in the opposite direction. It's going to cause it to turn around. It's going to cause it to slow down. Okay, and so if the the bike initially has a positive velocity, then the force that is stopping it has to be a negative force, which means you have to have a negative impulse. This, by the way, is something some of you had trouble with in the problem set because you had a graph just like this with a ball hitting a wall. Same idea. If the ball had an initially positive velocity, the impulse had to be negative because that's the only way that you're going to cause the ball to stop and turn around. Okay, on the other hand, if the ball's velocity initially was negative, then the impulse would be positive. Same idea here. Okay, so again, I drew a picture up here to help illustrate it as well, but if the bike is moving to the right, +6, then the force it feels when it hits the car is going to push back against it. It's going to be a force pair. The bike is going to push to the right on the car, but the car is going to push to the left on the bike, and that's the force that we care about here because that's the force on the bike. Okay, it would be 1 to the left, so it's negative. All right, so I have a negative impulse. From here, we're going to try to find final velocity. So you have many equations to choose from now. Final velocity shows up in 3 of your kinematic equations, which you can use if you happen to know initial velocity, time, acceleration, and displacement, or at least 3 of those. We don't have that. We only have 2 of those. So we don't have enough information as it is to use our kinematic equations. But final velocity also shows up in any equation that has delta V in it. And we know that change in momentum, delta P, equals mass times delta V. We also know that impulse is change in momentum. And so that's the equation we're going to use. We're going to say, hey, impulse is change in momentum. So impulse is m delta V. And of course, delta V is VF minus VI. So this equation right here, J equals m times VF minus VI, is the one we're going to substitute into because I know J, I know m, and I know VI. I can find that one missing variable, my final velocity. So plug in. And this is where the sign matters. You do need that negative sign here, otherwise you're going to get the wrong answer. Okay, so I have negative 450 equals 65 times VF minus 6. You've got options here in terms of how you want to approach this algebraically. You can distribute that 65 into the parentheses if you want. That's what I did. Or if you want, you could just divide right now both sides by 65. But I went ahead and distributed it to get this. Negative 450 equals 65 times VF minus, and then 65 times 6 was 390. From here, I'm just trying to solve for VF. I need to get it by itself, so I'm going to add 390 to both sides. When I do negative 450 plus 390, I get negative 60 equals 65 times VF, and then we're going to divide both sides by 65 to get a final velocity of negative 0.923 meters per second. Questions about how we got that final velocity? Okay, then let's do a second problem related to this. Instead of finding final velocity, which we already found, let's find acceleration. I went ahead and added my final velocity to my list of givens because we already calculated it. So now that we know that as well, let's see if we can figure out how to find acceleration. Again, I can find acceleration using F equals ma if I know the force and the mass. Problem is, I don't know the force. I could find it if I wanted to, or I could find acceleration using a kinematic equation if I know at least 3 of the variables VI, VF, delta x, and t. And I do. I know 3 of them, VI, VF, and t. So if I want to find acceleration from that, this particular kinematic equation is the one that would be most useful. VF equals VI plus a times t. Substitute in, and it looks like this. Negative 0.923 equals 6 plus a times 0.1. You're again trying to get acceleration a by itself, so we need to move that 6. Subtract 6 from both sides, and you get negative 6.923 equals 0.1a. and then divide by 0.1 since it's being multiplied. Divide both sides by 0.1 and you find your acceleration to be negative 69.23 meters per second. And from here we could find force or displacement or any number of other variables that I ask you for. Does anybody have a question about my acceleration calculation? Again, we've got a lot of formulas that we can pull from now, and so there are a lot of things we can calculate. So that does make it tricky, and that means you will want a formula chart in front of you while you're working today. Because when you work on this assignment 402.4, it's going to be similar to that warm-up where you're pulling from multiple units. Okay, so have some paper out so that you can draw a diagram, or maybe more than one. If it's like yesterday's problem with a hockey puck where it gets hit and then it slides, you've got two different sets of motion. You might want two different pictures. You're also going to have two different sets of givens if that happens. I didn't have that in today's problem, so you don't necessarily have to do that. But just make sure that you're drawing pictures and labeling things appropriately so that you can pick the correct equation based on the information you have. And if you can't figure out which equation to pick, then just start solving for anything that you have the information to find. And hopefully you'll find your way there. Okay, so if you looked at that and you're like, oh, well, I can find this even though I don't need it, cool, find it. Maybe that helps you see what to do next. Okay, so again, that's what this says. If you can't solve directly for the variable you're being asked to find, solve for what you can. As a little side note, in question 1 and question 2 today in 402.4, there is a little link at the bottom if you get stuck with a video tutorial where I explain how to work out at least my version of that problem. So if you get stuck, I'd recommend looking at that before you ask for help. Those particular questions, there are a lot of people had questions in years past, so I put videos in there. However, try it on your own first. Okay, I need you to try it on your own because you have to kind of struggle through to figure it out with some of these. One more reminder, bumper supplies are due tomorrow. Tomorrow we start our RA, where you're building a bumper. Again, the list of supplies, I wrote them on the board the other day. You are responsible for bringing those in for your group, so please make sure you have a quick discussion with your group and make sure everybody knows what they're supposed to bring. One last reminder, the video playlist on YouTube for this unit does contain lectures of me talking through the slides like what I just did, but it also has these solutions for the problem sets. 402.1, 402.2, and 402.3 are all posted now. So if you ran into problems with any of those and you have a question about, like, I couldn't do number 8 on 402.3, then open it up and take a look at the video and maybe that'll help answer your question. It's not identical to this year's assignment. Like the one yesterday, for example, had 3 extra questions added. They're not in the video, but at the very least, most of them are. So it's a good resource for you to use. All right, guys, go ahead and get to work. If you have questions as you're working, feel free to ask, or you can turn and chat with your neighbor and see if you guys can figure it out on your own at your table.